Okay, so now that you know a little bit more about sampling and we went over all of the different sampling methods that are commonly used in marketing research, we're gonna have a session about sample size. Because choosing a method is one thing, so selecting your units one way or another, that's just one part of the equation. You also have to choose how many of those units you will include in your sample. In other words, determining sample size. And this first session about sample size will be a little bit shorter because I'm going to introduce you to some concepts first. Now, sampling size really matters because it can save you a lot of money if you're calculating the correct sample size, because overdoing it is a waste. A lot of people mistakenly believe that a larger sample size will be better per se or will be more representative, and that is not the case. So I will actually give you those nuances in the next few sessions. So nonetheless, sample size is important because it really does involve a lot of costs if you overdo it. Now, a sample size decision is usually a compromise you make between what is theoretically perfect and what is practically feasible. Of course, a larger sample size is optimal in the sense of that it gives higher accuracy, which is theoretically desired or preferred at least, but not always practically feasible. So, like I said earlier, a lot of people have the wrong idea that a large sample will lead to more representativeness, and that's definitely not the case. So we call it large sample bias. Sometimes people ask, how large should our sample be to make it representative? And that literally is complete BS. Sample size does not influence representativeness. And this is exactly what I'm going to talk about in this very first session to give you some clarity on basic concepts in sample size. So sample size matters, absolutely, but it does not matter for representativeness, it matters for accuracy. And sample accuracy literally just means how close are your findings, so any result you find in your sample, to the true population's value. So in other words, let's say I gather a sample of marketing for 70 students and I ask all of you, what is your shoe size? And I add up all the shoe sizes, divide them by the total, so I calculate the average shoe size in my sample. So the average shoe size of my sample of marketing for 70 students. And now I want to know whether that average shoe size that I just found in my sample actually reflects the average shoe size of all marketing for 70 students. In other words, how close is my finding from my sample to a hypothetical or of course imaginary populations finding, if you were to do research among the whole population, which of course you don't, because that's why you sample. You don't have data on the whole population. I do not know the shoe size of every marketing 470 student, right? But if I gather a sample, will that sample give me an accurate estimate of what the population's shoe size will be? So all marketing for 70 students in this case. So this kind of gives you an idea already of what accuracy is. Accuracy really means how close are your findings from your sample to the truth. So to the actual population's findings that of course you don't know because you never asked the whole population. Now this idea of accuracy or closeness of your findings to the population's value is inversely related to sample error. High accuracy means you have small sample error. Kind of makes sense. If you have an accurate estimate, you have few errors, or you have little room for error. So that's a good thing. You want high sample accuracy. In other words, you'll have small sample error. So this brings me to two very important points that I put in the green frame here on this slide. Sample size is absolutely not related to representativeness, but sample size is related to accuracy. And I cannot talk about it enough. I mean, I really want you to fully grasp this based on the examples I just gave, that sample size indeed has nothing to do with representativeness, but is completely related to accuracy, in the sense that a larger sample means more accuracy, which means less sample error. Let me illustrate this point with one other example. So, why is there a relationship between sample size and accuracy, but not between sample size and representativeness? So let's say, for example, you want to know how very avid gamers perceive a new game you developed. Let's say you're a game developer, you came up with this awesome new game, but you want to do some test marketing, test it among a sample of very avid gamers. So if you have the false belief that a larger sample will lead to more accuracy no matter what, then you would just start gathering a large sample of people, completely ignoring the fact that they are or they are not avid gamers. So ignoring who you selected, just basically saying, oh, doesn't matter who, just gather a large enough sample and then hopefully we'll have more accuracy. Well, it doesn't work that way. I mean, you're gonna have an unrepresentative sample. So this whole idea of sample size influencing accuracy, so a larger sample being more accurate, only counts if your sample is representative to begin with. If you do not have a representative sample, then you can make your sample as small or large as you want to. It's still not gonna be any better. You're basically gonna have a big bad sample instead of a small bad sample. But if it's not representative, it's not representative. Now, how do you achieve that representativeness? Well, that is what I explained in the previous sessions about sampling methods. A well-chosen sampling method, so a probability sample, can yield representative data. And within that, so once you do have a representative method, then you can start tweaking the sample size, so making the sample size larger to accomplish greater accuracy, or in other words, smaller sample error. So these are some really crucial distinctions you have to keep in mind. Only when your sample is a probability sample, you're gonna have a truly representative sample, and only then the rule of larger sample being more accurate, or in other words, having less sample error, holds. So that's important to keep in mind. Your sampling method influences whether your sample is going to be representative. Your sampling size, of course, given that it's already representative, will give you more accuracy. So we will build on this in the next session, where we talk about a couple crucial concepts in sampling and sample size.